In this video, 8.2.4 zero product property, we're going to look at solving a quadratic using the zero product property, but it's going to be a little bit different than the first video you might have watched. In this case, we're going to see some more challenging situations. So remember, when we were solving a quadratic, for instance, a quadratic like this one, we started by factoring and turning it into a product. And then we stated, well, heck, if we have a product and it equals 0, like we see here, then either the first parenthesis has to equal 0 or the next parenthesis has to equal 0. One of the two factors has to equal 0. Now, this only works if the product that you saw here, if this product was 0. Okay? It only works when the product was 0. So we're going to see situations where we have a quadratic that equals maybe 10 instead of 0. And we're going to have to work with that 10 and make sense of it and figure out a way to solve the quadratic still using the zero product property. So let's take a look at those situations here. So here we have a quadratic. It's quadratic, remember, because it has the second power right there. So if it's a quadratic, we can't solve it by getting the x alone because there's two different x's, one's squared, one's regular. We can't solve it. So we're going to use zero product property, but our first goal now is to make it equal to 0. So I notice a lot of stuff over here. So the quick way to make this equal to 0 is to minus 2 from both sides. Because then I get 0 on the left, because 2 minus 2 is 0, equals 6x squared minus x minus 2. Now I can use the zero product property. So all this involves is one additional step to make it equal to 0. So now we're going to use our product, use our idea of changing this to a product by factoring it. So we'll put in our x squared and our constant, and then we'll use our diamond problem to figure out what the other two corners will be. In my diamond problem, I know that these two numbers that I'm looking for here, have to add up to negative x. But I also know that these two numbers have to have the same product as we see in the generic rectangle. So the product has to be negative 12x squared. Because 6x squared times negative 2 is negative 12x squared. So now I guess and check, what ways are there to multiply to negative 12? Well, we could do 2 times negative 6 or negative 6 times 2. But neither of those add up to negative x like I want. So I try some other things. Negative 4 times 3. There it is. Because negative 4 plus 3 is negative 1. So my solutions in here are negative 4x and 3x. So now I'm ready to put them in my generic rectangle. So in my generic rectangle here, I'm going to insert negative 4x and 3x. So now let's see, I get a lot of things going on. What could I put over here that would work with the 6x and the 3x? And I think a 3x would be best, because then this would be 1, the bottom right, and this would be 2x. And that works because the 2 works with the 6 and with this, so this would have to be negative 2. One big puzzle. So now it looks like I have my product. I can change this sum into a product of 3x minus 2, because that's the height that we see over here, times 2x plus 1, because that's the base we see down here. So I've changed my sum to a product. And since this product, remember, equals 0, then one of those two factors must be 0 for this equation to work. So now I go on to using the zero product property that states that since the product is 0, either 3x minus 2 has to equal 0, or the other product, the other one has to be 0, the other factor. So one of those has to be 0. So now I'm going to solve them separately. I'm going to solve for x, adding 2, 3x equals 2, divide both sides by 3, and I get x equals 2/3. Good to leave things as fractions whenever you can. So that's one solution. But the other solution we'll solve on the other equation. So we'll minus 1, and we'll get 2x alone equals negative 1 divided by 2. And we get x equals negative 1 half. There's my second solution. So we get two solutions. Once again, you'll be looking for more than one solutions very often. So these are our two solutions for x. We want to give both of them as an answer to this question. So the next question is going to be similar. We're going to look at another example here. A little bit different, but it's still going to be solvable using our factoring. So let's take a look. In the rule, y equals x squared plus 3x plus negative 3, when will y equal 7? So once again, I could guess and check. I could guess, well, let me see if 1. So remember, my goal is to see 7 right here. I could guess 1 and see if it works. I could guess 2 and see if it works. I could keep guessing, but we're mathematicians here. We're trying to be sophisticated, so we're going to plug in 7 for y, and we're going to take a look at what we get. We're going to get an equation with one variable. And in math, you can typically solve an equation that has one variable. So all we have is x's now. We don't have y's and x's. Now this problem looks a lot more similar to example 1. So we're now going to do exactly what we did in example 1, and we're going to get it equal to 0. And by doing that, the simple step to do that is to minus 7 from both sides. That gives me my x squared still, plus 3x, but now I have plus negative 10, or minus 10, whatever you want to see. Okay, so we got it equal to 0. Now we can do exactly what we've been doing, the zero product property. So now we're going to solve for x by using our factoring. We'll factor out our quadratic by putting in our x squared, our negative 10, and thinking through our diamond problem. So we're looking for a pair of numbers to go in our generic rectangle who add up to 3x, but multiply to the same product that we see here, negative 10x squared. Take a moment and try this. See if you can figure out the pair of numbers that would work here. Pause the video and try this on your own. Did you pause the video? Did you try it on your own? Did you get, for the two numbers that go in the diamond problem, did you get 5x and negative 2x? Because those two add to 3, but they multiply to negative 10. So these are my numbers that I put in my diamond problem, in my generic rectangle. Now the good news with x is the only way to get that x squared is to do x times x, so that's easy. And the rest of it falls into place nicely too. Negative 2 and 5. So remember, we rewrite this problem as 0 equals the product that's equal to the sum that they gave us. That was originally in our problem. So we've rewritten our sum as a product. Okay, this is a sum, this is a product. And once we have a product, we can use the zero product property. So now we ask the question, okay, and sometimes you can see the answer. Can you see it? Can you see what will make the first factor 0? What could we put right here for x to make that product 0? If you don't see it, you solve the equation. X plus 5 equals 0. You solve the equation that asks that same exact question, but in math language. When is x plus 5 equal to 0? We solve for x, and we get negative 5. Can you see the solution here? What would we put in for x to make 0? The solution here is 2, because 2 minus 2 is 0. So the other solution is x equals 2. Those are my two solutions to this problem. Remember, the problem was, when will y equal 7? So apparently, if I plug in 2, square it, plus 3 times 2, plus a negative 3, I will get an answer of 7. That's apparently what we're finding here. So we can check it to make sure it works. 2 squared is 4, plus 3 times 2 is 6, plus negative 3. Looks like it works because we get 10 plus negative 3, which is 7. So 2 works in my equation. And we can do the same thing with -5. Plug it in and see if it works. So the only additional thing you should have learned from this video that you didn't already know was that sometimes you're given an equation that is not equal to 0, and the first job is to get it equal to 0. And then it's the same as the other problems we've been doing. Okay? So we're going to write this down. Remember, before you can solve a quadratic, you must get it equal to 0. This is true for the zero product property, and it is true for the quadratic formula, which you will be seeing in the very near future. So be sure to ask your teacher questions if you didn't understand anything in this video. But try your worksheet and ask questions.